Hi, my name is Louise Zhuang, and this video will go over recent motivations and research efforts on improving automated poultry deboning. Currently, poultry is the second most consumed meat in the world. More than 100 million tons of poultry are produced each year, and demand is increasing annually. Deboned parts are especially popular, which requires more further processing steps that are typically performed manually. However, these processing jobs have 40 to 100% turnover and are very challenging. Existing deboning technology is also very specific to the exact cut performed, as well as chicken size and shape, which can result in high yield loss compared to manual deboning. In order to alleviate these problems, improvements to poultry deboning are necessary. Robotic deboning in particular shows promise as a solution to processing challenges. Robotic systems and sensors have become much more affordable over recent years, and computational power and speed have also increased to help support the real-time autonomous performance needed for online operations. Robots also have more flexibility in adapting to different chicken sizes and shapes than existing deboning systems. Current research in handling and trajectory generation have shown that high-yield robotic deboning can be viable, especially with increased research in the area. In order to support further automated deboning trajectory development, a good anatomical understanding is needed to determine the best cutting paths. Traditionally, imaging systems such as X-ray computed tomography or CT and magnetic resonance imaging or MRI are used to obtain accurate high-resolution 3D views of internal structures like bones, ligaments, and muscles. However, these imaging systems are expensive and slow and would be difficult to integrate on a poultry processing line due to the speed needed for operations. Developing a mathematical model for anatomical structures based on external features would be an affordable alternative that could be implemented for robotic processing systems. Our latest research focuses on making an anatomical prediction model. For our initial efforts, we worked on predicting the endpoints of the lateral and medial ligaments about the shoulder joint, which need to be severed for a wing deboning cut. These ligaments are labeled in the figure on the left, and the clip on the right shows a wing cut on an actual front half. The lateral ligament appears in a whitish color in the shoulder area. After cutting the ligament, the bones of the shoulder were able to separate relatively easily at the top. The cut ligament is still visible on the two sides. An initial anatomical prediction model was developed in a virtual reality simulation environment where chicken mesh models of the bone, body, and key soft tissue structures around the shoulder joint were generated from CT and MRI scans. Points were placed at ligament endpoint locations for model training, and the model was computed so that external reference points for each training chicken were linearly related to the key internal ligament endpoints for the wing cut. Evaluation of the model using external reference points on test breeds of different sizes showed the mean endpoint accuracy to be within 4 millimeters. With more data and model improvements, future developments in poultry processing can be made. Automated deboning trajectory generation can be improved with anatomical information so that trajectories are more optimal. Future deboning trajectory paths could even be calculated by a computer rather than determined through manual training of a trajectory model to further optimize paths and movements for a robotic arm. These improvements would enable the next generation of robotic deboning to meet the growing demand for poultry while also providing high yield. In addition, using virtual reality as a development tool opens up possibilities for numerous applications, including greater research and industry collaboration and remote interactions. VR can also serve as an immersive and easy-to-understand training tool for new workers. With further research, these new poultry processing systems will advance closer to full implementation.